right, so 315 is the average rate of change of polar functions. The great thing about this is, one, it's going to help us review polar functions, and two, it helps us review rate of change, which was from early unit 1. So you're getting some review from the beginning of the content as well. So we start with basically just a review of where we left off. You're going to consider the polar function r of theta equals 3 cosine 3 theta. And then we're going to find the distance from the center at each theta value. Now, I already graphed it for you. Like, you don't have to graph it full out, although at some points in the day you will do that in the notes for this section. But what we're going to do is find the values at each of the thetas that are given. So it's pi over 6, pi over 4, and pi over 3. I'm just going to take those and plug them in. So 3 cosine 3 times pi over 6. We're going to simplify. 3 goes into 6 twice, so this is 3 cosine pi over 2. And what's the cosine at pi over 2? 0. So this is 0. And we're going to repeat it for pi over 4. So 3 cosine 3 times pi over 4 is 3 cosine 3 pi over 4. What's the cosine at 3 pi over 4? Negative root 2 over 2. Good. This becomes negative 3 root 2 over 2. And then we're going to approximate this. So there are going to be questions as we work through today where you have to like picture, what would this be like if I didn't have a calculator? And then what would this be like if I did have a calculator, because some of them are going to be separated out. So I can start, like, you're going to get root 2 over 2 a couple of times. Maybe you want to start to, like, do that part first, then multiply it times the root 3. If I start there, we said to approximate root 2 to what? Like a 1.4. So this would be negative 3 times 1.4 over 2. What's 1.4 divided by 2? 0.7. And then negative 3 times 0.7 would be? Good, negative 2.1. Then I repeat it again, but this time for that last value, which is pi over 3. So 3 cosine 3 times pi over 3. 3's cancel, and I get 3 cosine pi. What's the cosine at pi? Negative 1. So this is negative 3. So now go to your graph. Like, does this make sense with our graphs? At pi over 6, which would technically, so this, when you only see 2 lines here, this one's your pi over 6, this one's your pi over 3. The middle one, which is not even drawn there, would be pi over 4. So pi over 6 is 0, which makes sense. That's at the origin. Pi over 4 is negative 2.1. So I'd go in the opposite direction, 2.1. Which is that point. And then pi over 3 was negative 3. Pi over 3 is this, right? I go in the opposite direction to 3, and that's that point. So this was my pi over 6. This is my pi over 4. This is my, pi over 4, and that's my pi over 3. So the bottom question is kind of what the focus of today's lesson is comparing the values. What's happening as these values increase? So it says compare the values as your angle values increase. The distance from the center, we're looking for increases or decreases here. So if I go from where pi over 6 was, which was that first point, to pi over 4, which was the second point, the teal point, to pi over 3, which is the pink point, what's happening to the distance from those points to the center? Is it increasing or decreasing? It's increasing because those points are moving further away from the center. That first point is literally at the center. Then the second point is 2.1 away from the center. And the third point is 3 away from the center. Now, when we talk about distance from the center, we're talking about distance. Is distance negative? No. So if it asks what's the distance from pi over 3 to the center, it's 3, not negative 3, okay? It's important to understand the signs because we're going to learn a trick to talking about decreasing and increasing distance. But when you're talking about the actual distance from the center, you ignore the sign, okay? And in this case, that would be increasing from the distance from the center. And this is where it gets super confusing because it's going to ask you, are the points increasing and decreasing, or is it the distance from the center increasing and decreasing? And those are two different things, okay, because the signs change. All right, and that's what this is. So changes in the distance from the center. Some of this you can like kind of just look at and understand, but also if you're not looking at it, if you don't see a graph, it might be easier to learn this kind of trick. So if r is positive, if our radius is positive and the values are increasing, to me this makes sense. Like if the r's are positive and they're getting bigger, you're getting further from the center. So the distance from the center to the point is increasing. So that's the first one. R is positive and the points are increasing. They're getting bigger, so they're getting further away from the center. Yep.
But when you say increasing, like
this increasing is the distance from the origin is increasing.
so like our answers from when we plugged in things.
Sometimes you're going to actually have to plug them in, and sometimes you'll actually see it on the graph already. Like sometimes they'll just give you the graph, and you can plot some points, and you can see it's increasing or getting further away. Yep. And then also, to me, it makes sense on the decreasing side, if r is positive, but decreasing, so it's getting smaller as you go further away, then that distance is decreasing. To me, the positive is kind of easier to understand. If they're positive and getting bigger, the distance is increasing. If they're positive and getting smaller, the distance is decreasing, okay? Now, the negative is where it gets a little bit weirder. If r is negative and decreasing, and we're not talking about value, like you can't ignore the sign there, right? The bigger the negative number, the smaller it actually is, right? Negative 10 is smaller than negative 5, yes? So that you have to kind of pay attention to the sign there. If it's negative and decreasing, then the distance between your center and the point is increasing. So if I were to just draw a graph. Okay, let's do the whatever. I don't even remember. Did I have 4 petals in the last one? Let's just say they're the petals, okay? So the r values are negative here, let's say. If I put a point here, and then I put a point here, those r values are negative. Right? As I go from purple to green, what's happening to my R value? It's decreasing, right? Because this negative is smaller than that, is bigger than that negative, yes? So if you look at it, it should make sense. I would say these values are decreasing, but the distance from the center is actually what? Increasing, okay? So the smaller the negative, the further it is from your center, so then we would say the distance is increasing. Now, if the r is negative and it's increasing, if I go back the other way, if I say what's happening from here to here, now my r value is actually increasing. Even though it's negative, it's increasing, and the distance from the center to that point would be decreasing. Does that make sense? Okay, the increasing, decreasing thing is a lot of language, like weirdness, so just make sure that totally makes sense. Bella.
Wouldn't the purple, the dot be like, wouldn't that be a larger value?
Yes, it's a larger value.
So why is it farther?
So if you're comparing the r's on those 2 points, the r, if you're going from teal to purple, we're saying, the r is increasing, but the distance from the center is decreasing.
Yes.
Does that make sense?
Yeah.
So when it's negative,
What do you mean by the R increasing?
the r, let's say this is 1 ring, and let's say this is 2 rings. Let's just make it like that. This point, that r, is negative 1.
Oh, so it's increasing.
And this r is negative 2. So the r value is increasing. Does that make sense?
Yeah.
But the distance from the center is actually decreasing. So when it's negative, the distance from the center is the opposite of it.
Okay, that makes sense.
Okay. The other thing is, like, if they're both the same sign, you can just compare the absolute values of your radii. If they're both negative, then I can make them both positive, and the smaller is going to be closer to the pole or to the origin, okay? And again, if that confuses you, you have to just understand this box. You have to understand if it's positive and it's getting bigger, then the distance is increasing. If it's positive and it's getting smaller, then the distance is decreasing. I don't think that's the hard part. It's when it's negative. When it's negative and decreasing, then the distance is increasing. When it's negative and increasing, then the distance is decreasing. The negative is when it's flipped.
When you mean increasing, you mean the points, right? Like
The first thing we're talking about, yes. So if the value of R is increasing, then which one are you talking about? Like the negatives? So if I go to that, this one. If the value of R is negative and also increasing, then the distance between the point and the origin is decreasing.
what do you mean by increasing?
Like your actual values are getting bigger. So that would be from going from -2 to -1. Because on my number line, right, picture a number line, -1 is to the right of -2. So the values, even though they're negative, are increasing. Does that make sense? It's the negatives that are confusing. Like if I had an R that was -5 and an R that was -5.2. And I'm talking about the change between the first and the second. Is -5 bigger or smaller than -5.2? -5 is bigger. So these values are decreasing, but the distance from the origin is actually increasing. Because if I have an origin, right, -5 is going to get hit before -5.2. So this on a number line is one thing. -5 would actually be to the right of -5.2. So -5 to -5.2 is decreasing. But from your origin, the -5.2 is further than the -5. So we're moving away from it. Does that make sense? So positive, increasing. Positive, decreasing. Those match up. Negative R's are the opposite. Negative R, increasing coordinate point, increasing R is actually the distance is decreasing. But a negative R that is decreasing, the distance is actually decreasing. Did I say that wrong? So a negative R that is increasing, the distance is decreasing. It's the opposite. A negative R that is decreasing, the distance is increasing.
And the -5 and the -5.2 example matches with the second one. Right?
If you're going from -5 to -5.2, your value is decreasing, so the distance is increasing. This one, that's what you mean? This one? Yes. But if I reverse it, if I say if I'm going from -5.2 to -5, now it's the other way. Does that make sense? So the order of what it says is important. Okay, so example 2 says graph the polar function r of theta equals 1 minus 2 sine theta and determine if the polar curve is getting closer to the origin or further from the origin or neither when theta is pi over 6. So we go back to actually graphing this. What kind of polar function is this? It's a limison, specifically the loop, okay? What kind of symmetry does it have? Pi over 2. So I'm going to plot some points for my first quadrant and then flip it over. And we're going to use the trick that we talked about yesterday with our R. What's the biggest R? 3. 1 plus 2, right? We add the A and the B. So if I want to find where that happens, I'm going to say 3 equals 1 minus 2 times sine of theta. Subtract the 1. 2 equals -2 sine of theta. And sine of theta equals -1. And where is sine -1? 3 pi over 2. So 3 pi over 2 is where a radius of 3 happens. 1, 2, 3. That's going to be the rounded end, which means the loop is happening at the top. So I'm going to plug in coordinate points for angles from my first quadrant. I'm going to plug in 0, pi over 6, pi over 3, pi over 2. 1 minus 2 sine of 0. What's the sine at 0? 0. So 1 minus 0 is 1. 1 minus 2 sine pi over 6. What's the sine at pi over 6? 1/2. Good. 1 minus 1, which is 0. Then I'm going to do 1 minus 2 sine pi over 3. What's the sine at pi over 3? Root 3 over 2. The 2's cancel. And I get 1 minus root 3. We're going to approximate root 3 to be what? 1.7. So 1 minus 1.7 is negative 0.7. And the last one, 1 minus 2 sine pi over 2. What's the sine at pi over 2? 1. 1 minus 2 is negative 1. Now I'm going to plot these points. So at 0, my r is 1. At pi over 6, it's 0. At pi over 3, it's negative 0.7. So I'm going opposite direction, just under 1. And at pi over 2, it's negative 1. Opposite direction of pi over 2 to the first ring. With me so far? Now I'm going to reflect every point that's on the right is going to happen on the left. So at 0, I'm going to reflect it over to the pi side. At 4 pi over 3, it was negative, or it was at 0.7. So I'm going to do the same thing at 5 pi over 3, 0.7. And I know it's a loop. So this is going to come around, come in here, come back around. That was a really bad loop. Come around. Loop and back around. Okay. So now it wants you to determine if the polar curve is getting closer to the origin or further from the origin, or neither, when theta is at pi over 6. So I need to know the behavior that leads into pi over 6. So what happens before pi over 6? And then what's happening at pi over 6. So I want to know the motion before it, okay? Because at a single point, obviously, you're not going to get motion. You're not going to get movement. So as I go from 0, where my radius is 1, to pi over 6, where my radius is 0, what's happening to my r value? It's decreasing. Would from 1 to 0 be a positive r or a negative r? Between 0 and 1, are those numbers positive or negative? Positive. So my r is positive, and my distance is decreasing. So is it getting closer to the origin or further from the origin? It's getting closer to the origin. So at 0, my r was 1. At pi over 6, my r is 0. These values are positive. 0 could be either, but those values in between would be positive, positive r, and the values, and they are decreasing, right? From 0 to 1 would be decreasing. So the distance from those points to the origin are getting closer or decreasing. Yep.
Why is 0 to 1 decreasing instead of
Because we're going 1 to 0. So you go from the point before, which at 0, it was at 1. So like if you actually graph this on your calculator, you'll see it start here at 0. You'll see it move in this direction. So if I just compare here to here, because that was my point, that was my pi over, right? Pi over, yeah, that's my pi over 6. Then the distance from those points to the center are decreasing. But the goal is, sometimes you're going to have to visualize it, but sometimes you don't have to visualize it. Sometimes you're just going to get the r. and you'll want to know, is it positive, is it negative, is it getting bigger, is it getting smaller? So because these are both positive and the values are getting smaller, the distance from the curve to the origin is decreasing. And in these words, it says getting closer, but those mean the same thing. So the distance is decreasing. Okay, that would be the same thing as getting closer. Questions on that one? About this on my rectangular coordinate grid. So go back to the beginning of unit 3. What kind of graph is this, like sinusoidally wise? Okay, it would be -2 sine of theta plus 1. What's the negative do? It's over the what? The x-axis. What's the 2 do? My amplitude is 2 or vertical stretch. What's the plus 1 do? Shifts it up 1. So if I could just get an approximate graph on this, my key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi, because my period is the normal period. And it would normally, sine would start at 0, go up, down, up, but it's a negative. So it's going to start at 0, go down to 2, come back up to 0, come back up, and come back down again. It would look like that without your vertical shift. And then everything's going to get shifted up 1. So it's going to start at 1. It's going to go from there to negative, or from to negative 1, back up to positive 1. It would go up to 3 and back down. So you don't have to be exact, but understanding that pattern might also help you understand your increasing and decreasing behavior, right? So if I want to know what's happening from 0 to pi over 6, I'm literally right here. What's happening to those values? They're decreasing. And if my origin is my midline, you're going from, no, actually don't look at it that way. Just look at it like the increasing and decreasing. Don't even try to pull the origin over. So you can kind of see the values like that. It will ask you, are those values increasing? Are they decreasing? And then from there, you can figure out the distance from your origin. Only use that to figure out, are my values increasing and decreasing? Like there's a question on AP that like it made to me more sense to see it visually like that to figure out the increasing and decreasing behavior than it is to do it the other way. You still have to know, are you moving closer or further away? But if the values are confusing, you can always look at it that way. All right, now let's talk. Yep.
Is that what the test was?
No. All right. So relative extrema. We go back to thinking about extrema, right? Extrema is your maximum and your minimums. Relative because it's not absolute, right? These things, if I don't restrict them, they're going to keep continuing on in this pattern, right? So the biggest point can be the biggest point on this interval, but it will continue to be the biggest point on interval after interval after interval. So the relative extrema is why we say, well, that's why we say relative extrema. This occurs at a max or a min. The relative max occurs when the graph changes from increasing to decreasing. So is it getting bigger and then smaller? Yes, that's a relative max. Is it getting, and then, or the opposite, if it's decreasing to increasing, then there's a minimum. So on this graph, this is a circle, right? If I'm moving towards, excuse me, pi over 2, and I hit this point, these values, these R values are what? Increasing or decreasing? Increasing. As I move away from what are those R values doing? Decreasing. So this point here is called a max, relative max specifically, okay? So relative max. And it could say, where is the relative max? And from this graph, we read that at pi over 2. It might have been at 3 pi over 2 with a negative, but without knowing that, without knowing the equation, we read that as pi over 2. So where does it happen? It's where theta equals pi over 2. What's the max? Is the R value, which in this case looks like if this is 2. Actually, this is 1, 2. That's a 3. Okay? So it could ask both parts. Where is the max? And then what is the maximum value or the relative max? Okay? Now, this coordinate point here, this R is what? The R at the bottom there. R is 0. This is going to be a minimum. As I move towards it, the R is decreasing. As I move away from it, the R is increasing. It's changing from decreasing to increasing. So this is a min, okay? And again, without an equation, we're just going off the graph, we assume that that is at 0 and that our minimum value is actually 0. So you'll either see this from a graph where you've got to like kind of plot those points, or you'll see it from a chart in which you're going to get given values, or you'll have to plot points and you'll use those values to determine it. So example 3 says, consider the curve r of theta equals -3 minus 2 cosine theta. Determine if the polar curve has a relative extremum on the following interval. If the curve does, classify it as a relative max or a relative min. So this is already graphed for you, okay? Where is negative pi over 4 happening? Where's negative pi over 4? 7 pi over 4, good. Or in my fourth quadrant, right? This one here, this would be negative pi over 4. And the R value is here on that one. Then it wants you to go to positive pi over 4, and positive pi over 4 would be here. And the R value is here. Now the question is, what's the behavior of the R values as I move from one to the other? And order is important, right? So as I move from negative pi over 4 to positive pi over 4, what's happening to my R values? They are decreasing and then increasing. So is there a relative max or min? If my direction changes, if the R values change from increasing to decreasing or decreasing to increasing, there is. So this is going decreasing to increasing. There is a relative extrema. And if I'm going from decreasing to increasing, that coordinate point is a max or min? Min. And what's theta where that's happening? 0. Now here's the other thing you can do, which is good to review because we need it anyways. What does this graph look like on a sinusoidal function curve, right? It's upside down. What's the 3 doing? The down 3. This is upside down over the x. What's the 2? An amplitude of 2, or a vertical stretch, right? So if I just approximate what this looks like, there's no period shift here, right? Then I would have a cosine curve that goes down instead of up. So it normally starts at the negative amplitude. It would start at -2. It comes back up to 0. It goes back up to +2, comes back down to 0, and goes back down to -2. And then it's shifted down 3 places. So all the way down here at -5 is where this is happening. Something like that, okay? Our quarter points are our pi over 2. This one's pi, and this one's 3 pi over 2. So where would negative pi over 4 and positive pi over 4 be? Negative is actually over here, right? This would be negative pi over 2. And my curve, well, I shouldn't have put the x-axis there. Sorry, hang on. All the way up here, negative pi over 2 would cause this curve to come up, so it would come back up again. So this around here is where your negative pi over 4 is, and this around here is where your positive pi over 4 is. So look at that graph. Does my graph change direction? It goes from decreasing to increasing, and there would be a relative min there. So if the polar graph confuses you, every single one of these can be re-estimated on an XY axis, and you can look at the increasing and decreasing behavior there, okay? But we're really looking at the increasing, decreasing behavior of your R values. All right, I think it gets easier with a chart, hopefully. Okay, so this one says the table gives all the relative extrema. F of the polar function R equals F of theta. So it's going to start to describe the graphs as this. That just means a polar graph. That's all that means, okay? For all the input values of theta in the domain of the polar function. There's like 17 extra words in the instructions of all of these. It just means here's a graph of a polar function, or here's the table values of a polar function. What's the greatest distance between F of theta and the origin? So this is your actual graph, your polar graph. And then obviously the origin is where it crosses. So if I go from a radius of 1 to a radius of -3 to a radius of 2, which one has the biggest distance away from the center? -3. What is the distance, though? Just +3. That one's easy, right? We like those. Yeah, okay. All right, now we go rate of change. So again, we go back to like unit 1 rate of change, which is good to review. Find the average rate of change in rectangular coordinates. To do this, we do f of the second point minus f of the first point over second minus first, okay? And honestly, order doesn't matter as long as you're consistent. But you're gonna get given an interval. Sometimes you get given the coordinate points and you literally just have to find it. Sometimes you have to plug in those points to find the r and then use them to find your average rate of change. These, you'll see two different ways. One, keeping it exact without using a calculator. God bless you. And they might be weird, but you're going to find it that way. And then it might also say find it using a calculator, okay? Okay, we're finding the average rate of change from pi over 6 to pi. So from pi over 6 to pi. So I'm going to do f of pi minus f of pi over 6 over pi minus pi over 6. And f of pi is 3. And f of pi over 6 is 1 minus root 3. And I'm putting in parentheses because that negative is going to get distributed to both of those. Over, I need to find a like denominator down here. So 6 pi over 6 minus pi over 6 is 5 pi over 6. So now distribute this. And I get 3 minus 1 plus root 3 over 5 pi over 6. Or 2 plus root 3 over 5 pi over 6. God bless you. Now it said to keep it exact and I can't keep it complex. I can't have a complex fraction. So I can't have the fraction within the fraction. So instead of keeping it as over 5 pi over 6, I'm going to multiply by the reciprocal, 6 over 5 pi. And I'd get 6 times 2, which is 12, plus 6 times root 3, 6 root 3, over 5 pi. And that is my rate of change kept exact without a calculator. So some of them are going to look weird. It's okay. You with me so far? God bless you. Then it says find the value given your calculator. So I can go off of what I just did. So I'm going to use the like fraction function in my calculator. 12 plus 6 root 3 over 5 pi. 1.4255, so 1.426. So without a calculator and then with a calculator. Now, if it didn't ask for without the calculator first, I could have gone like from this step. I could have gone from the first step and just typed it in the calculator. I would get the same answer. But it did say both because some of the questions are going to be kept exact and some of them you'll use a calculator for. All right, now the next part says, well, questions so far on that one. So what does that tell you? What does your rate of change tell you about your increasing and decreasing behavior? If it's positive, what's going to be happening? It's going to be increasing, right? So if it's positive, it's increasing. You'll also get a question where it says, like, compare the two rates of change. Which one is faster? The bigger the number, the faster the change, right? Okay. It says if the value of f of 2 pi over 3 is estimated using the average rate of change, compare the predicted value to the actual value. Okay, this process is weird, but once you get it, it should be easy. We are going to pretend like we don't know what 2 pi over 3 is or what the r at 2 pi over 3 is yet. We're going to find it and then we're going to compare it to the actual value, okay? So I'm going to find the rate of change from 2 pi over 3 to either direction. It doesn't matter. I can either go one up from there, I could go one down from there, okay? But I want to go to the next key point. I don't have an after. I'm just going to, like, there's not more to this chart. I'm just going to pick these two. So you don't want to skip, but you want to pick one. You can go in either direction. And those don't even make sense, like, in order of left to right. It doesn't matter because 2 pi over 3 is actually smaller than pi over, right? You just want the one next to it, okay? The key point next to 2 pi over 3. Closest there would either be pi, or if I had it, it would have been 5 pi over 4. I mean, 3 pi over 4, but I don't have that. So I'm going to say f of 2 pi over 3 minus f of pi over 2 pi over 3 minus pi. So I'm doing the rate of change. And that should equal my average rate of change. What's my average rate of change? 12 plus 6 root 3 over 5 pi, or 1.426. We'll do it once with the rounded number, and then later on in the notes you'll see we'll keep it exact. But for this one, it wouldn't be as complicated as that. So you'll keep it. I'll do the rounded. Now we're acting like we don't know f of 2 pi over 3. So I'm literally going to make that a variable so I don't have to keep writing it. Like I'm going to make that x. So I'm going to say x minus, what is f of pi? 3. Over 2 pi over 3 minus 3 pi over 3 would be negative pi over 3. And that equals 1.426. Yep, I'm setting it equal to the rate of change I found. And then I'm going to multiply by negative pi over 3. And I get x minus 3 equals 1.426 times negative pi. No, I'm not. I'm getting rid of it, so I multiply by it. If I was doing it on the same side, that's when I keep change flip it. But I have to move it out of the denominator, so I'm multiplying. Divided by 3. X minus 3 equals negative 1.493. And then I add the 3. And I get x equals 1.5067. So 1.507. So that's the predicted value, right? This is if I use my average rate of change. That's what it was predicted to be. Now compare that to the actual. What's the actual at 2 pi over 3? 2. So is it an overestimate or an underestimate? Predicted is what compared to actual? Predicted is under. So predicted is an underestimate. And even like there's a question on your AP Classroom, by 2 minus 1.507, 0.493. So there's a question on your AP that asks you to compare them. All right, example 6 says, consider the graph of the polar function r equals f of theta, again, where f of theta is 3 sine theta in the coordinate system. Find the average rate of change for the function over the interval of 0 to pi over 3. So I'm going to first find the average rate of change, right? So f of pi over 3 minus f of 0 over pi over 3 minus 0. And then I plug in. So f of pi over 3 equals 3 times sine of pi over 3. What's the sine at pi over 3? Root 3 over 2. So there's a couple different ways to do this. I can make like 3 over 2, 1.5, and multiply it times 1.7. You could do this a couple different ways. But this would be 3 times... And we said yesterday we would approximate that to be 1.7. You could even make it 1.8 if you wanted life to be easier and make it a rounded number. It's an estimate, so it's fine, okay? So if I wanted to do that, I would make it 1.8 over 2. And 1.8 divided by 2 is what? What's 18 divided by 2? 0.9, and 3 times 0.9. 2.7. So we're approximating here, okay? So 2.7 minus, then I have to find f of 0. 3 sine of 0. What's the sine at 0? 0. Over pi over 3 minus 0, which is going to be pi over 3. So now if I actually, like you'll find this using your calculator, 2.7 divided by, group together your pi over 3. And I get a rate of change to be 2.578. Then A says determine if the function is increasing or decreasing on the interval. How do I determine that?
If it's positive or negative.
Good. Is your average rate of change positive or negative? Positive, which means it is increasing. Then it says determine if the distance between the point on the curve and the origin is increasing or decreasing. So for these, I need to know the sign on the R, right? And I need to know if it's getting bigger or smaller. So what were the signs on my R's from pi over 3 and 0? Positive or negative? What was f of 3? Positive 2.7. F of 0? 0, which could count as positive or negative, right? So are the values between 2.7 and 0 positive or negative? Positive. And what's happening between 2.7 and 0? It is, so actually think you're going this way, right? It's increasing, right? Which makes sense because our rate of change is increasing. So if they're positive and increasing, what's happening to the distance from the origin? It's increasing.
I'm still confused on what you're looking at that's increasing.
So like you're looking to see if the R's are, if you use the shortcut things, you're looking to see if the R is positive or negative. So from 0 to 2 pi over, or to 2.7, those values would be positive. So your R's are positive. Then you're looking to see are the R's getting bigger as you go from the first angle to the second angle, or are they getting smaller from the first angle to the second angle? We already found the average rate of change, and that's positive, which tells you it's getting bigger. But you could have gone back to your original and said now this is, the order is different when you do rate of change or if you do the increasing, decreasing. From 0, where it's 0, to 2.7, those values would be getting bigger. So because they are positive and also getting bigger, they are moving further away from your origin, which means the distance is increasing. Does that make sense? Okay. And you could fall back on a sine curve that has an amplitude of 3. You would look between 0 and pi over 3, and your values would be increasing, which means that they would be moving further away. The origin is now your x-axis. Does that make sense? Okay. All right. Example 7 says complete the values. I might do this quickly so that we can get to the point of it, to the meat of it, okay? But it says given the polar function is f of theta equals, there should be an equals here, 4 sine 2 theta, complete the table values, okay? First of all, what kind of polar graph is this? It's a rose. How many petals does it have? 4. What's the length of each petal? 4, okay? So I'll kind of go through it quickly, but you would plug in each of these values if you had to, okay? So 4 sine 2 of 0 is 4 sine at 0, and sine at 0 is 0, so this is 0. 4 sine of 2 times pi over 4 is 4 sine pi over 2, and that's 1, so 4 times 1 is 4. And 4 sine 2 times pi over 2 is 4 sine pi, which is 0, that's 0. And 4 sine 2 times 3 pi over 4 is 4 sine 3 pi over 2, and that's negative 1, so that's negative 4. And then at 0, there's a pattern forming here. At pi, it goes back to 0. And then it would go to positive 4, and then it would go to 0, and then it would go to negative 4, and then it would go to 0. You would have plugged in all those points, okay? But we're going to save ourselves a lot of work. I'll just give you that pattern, okay? So if you think about this is a rose, right? It starts at 0, and then it says at pi over 4 it goes out to 4, then it comes back into 0, then it goes out to 4, then it comes back into 0, then it goes out to negative 4, then it comes back in, then it goes to negative 4, and it comes back in. So it would just keep repeating like that, okay? So A says find the average rate of change between 3 pi over 4 and pi. So I'm doing f of pi minus f of 3 pi over 4 over pi minus 3 pi over 4. And f of pi, from my chart, I already found it, is 0. Minus f of 3 pi over 4 is negative 4. Over pi would be 4 pi over 4 minus 3 pi over 4. And I get 4 over pi over 4. And then I multiply by 4 over pi to keep change, flip it, and I get 16 over pi. This is much more like the one that's on the homework that you have to do without a calculator. This is your average rate of change. B says use the rate of change to estimate the value for of R for theta being 5 pi over 6. So I want to go from the one before 5 pi over 6 to 5 pi over 6. Which of these falls before 5 pi over 6? 5 pi over 4. Good. Before 5 pi, yeah. You could also go to pi if it's easier. So I could go one before or one after, okay? Because it would fall in here. We could either use pi or we could use 3 pi over 4, as long as you're consistent. So again, just to make it easier, we're going to use pi. So I'm going to do f of pi minus f of 5 pi over 6 over pi minus 5 pi over 6 equals my rate of change, which is 16 over pi. Now we're using, God bless you, we're using it to estimate the 5 pi over 6. So we're going to make that our variable. We're going to say this is our x. We're not using the one from the chart. The rest of the information we're getting from the chart. So f of pi is 0 minus x over, this is 6 pi over 6 minus 5 pi over 6, so pi over 6 equals 16 over pi. That equals your rate of change. So I get negative x over pi over 6 equals 16 over pi. I'm going to get rid of the pi over 6 by multiplying both sides by pi over 6. Negative x equals, the pi's cancel, 16 over 6 is 8 over 3. And x equals negative 8 over 3. So that's our predicted value for 5 pi over 6. If it doesn't say use a calculator, you're going to keep it exact just like that, okay?
Why did you use pi? Like, it was
You can use one before or one after, as long as you have them.
5 pi over 4 before.
5 pi over 4 would be way after. That's too much of a jump. That's too, right? Because this is where 5 pi over 6 would be. 5 pi over 6 would be in between 3 pi over 4 and pi. So you could use either of those. We just picked the 0 because it was easier. Okay, C says on the interval is the distance between the origin increasing or decreasing. So are my R values positive or negative between -4 and 0? Not increasing or decreasing. Are they positive or negative? So between -4 and 0, are those values negative or positive? They're a negative R. What's happening between -4 and -8 pi over 3? Do -4 and 0, it's the same. What's happening to the values? They are increasing. So if it's a negative R and they are increasing, what's happening to the distance? Decreasing. The distance is decreasing. If they're both negative, then it's positive and increasing is getting further away. It's increasing. Positive and decreasing, they're getting closer. It's decreasing. The justify your answer is the R values are negative. So negative R's. R values increasing mean that the distance is decreasing. It's getting closer to your origin. The distance is decreasing. So the values were increasing, but the distance is decreasing. All right, D says identify the extrema of the function. Just look at my values. What's the minimum value? -4. What's the maximum value? +4. Where are those happening? Where are the minimums happening? At 3 pi over 4, at 7 pi over 4. And where are the maximums happening? Pi over 4 and 5 pi over 4. Okay, so it's going to actually, on one of the questions, it will actually ask you to list them. Questions on that? All right, this next question is something similar to what you're going to see in the AP classroom homework. It says, consider the graph of the polar function r equals f of theta, where f of theta is this big old nasty thing. 3 times theta squared minus 1 over 2 times theta squared minus 3 in the coordinate system. And then find the behavior of the graph. And it's really focusing on the end behavior as theta approaches infinity. So when you think about this, it goes back to this is a fraction with a variable in the bottom. So this goes back to our rational functions and our horizontal asymptotes. So we're going to review real quick our rational function, horizontal asymptote. So the horizontal asymptotes, remember that there's 3 different scenarios. One where the exponent in the top, so we're focusing on the exponent in the top being x of n and the bottom being m. So if the exponent in the top is smaller than the one in the bottom, then there's a horizontal asymptote at y equals 0, which means the limit would be 0 in both directions. If the exponents in the top and the bottom are equal to each other, then the horizontal asymptote occurs at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. And if there is no asymptote, so if the n is bigger than the m, then there's no horizontal asymptote. And this is where we focus in on just the leading term in both the numerator and the denominator. We would, so like let's say it was x to the third over x to the second, we would then cancel through and keep it as x. And then if we want to know as it's happening to infinity, we plug in infinity. And if we want to know as it's happening to negative infinity, we would plug in negative infinity. And then simplify it, and that's how you can tell the end behavior on either side. So in this example, we look at our exponents, they're the same, which means we're doing the leading coefficient part. And the leading coefficient in the top is 3, and the leading coefficient in the bottom is 2. So the limit on either side would be y equals, well, I don't need the y equals because it's f of theta. It would be that equals 3 over 2. This last example goes all the way through from graphing the curve, stating where it's 0, finding the intervals where it's positive and negative, and then increasing and decreasing, and then talks about the distance from the pole. So A says graph the curve. So we're going to graph this. 5 sine 2 theta would be a rose. It has 4 petals. And the length of the petal is 5. And it has symmetry to the pi over 2 line. Now we're going to plot this on the interval from 0 to 2 pi. So I'm going to plug in 0. I'm going to plug in pi over 4. I'm going to plug in pi over 2, 3 pi over 4, pi, 5 pi over 4. I'm going to add on 3 pi over 2, 7 pi over 4, and 2 pi. So these can change. These are just the ones that we're going to do for this one. And so for these, I'm going to plug in these values. So at 0, 5 sine 2 times 0, 5 times 0, this would be 0. 5 sine 2 times pi over 4, 5 sine pi over 2, that's your 1. That's where 5 is. And then 5 sine 2 times pi over 2, 5 times sine, sine of pi, which is back down to 0. 5 sine 3 pi over 4 times 2. So 5 sine 3 pi over 2. Negative 1, and there's our negative 5. So because it's a rose, we know it goes in a pattern. It comes back up to 0. It goes up to positive 5, back down to 0, negative 5, and back up to 0. So if there's a rose, we know it follows that pattern. I don't have to plug in all those points. Now think about what's happening for B. It says state the value of theta where f of theta equals 0. So this is happening everywhere it's 0. 0, pi over 2, pi, 3 pi over 2, and 2 pi. C says find the intervals where r is positive or negative. So think about your values as they're going from one to the next. From 0 to 5, these would be positive. 5 to 0 would still be positive. 0 to negative 5 are going to be negative. Negative 5 to 0, still negative. 0 to positive 5, positive. positive, 5 to 0, positive, 0 to negative 5, negative, and negative 5 to 0, negative. Now it says state, so if I was going to give those intervals, positive, I would do all the positives. So from 0 to pi over 4. Actually, goes 0 all the way through to pi over 2. Then pi to 3 pi over 2. It's negative. It's negative on the interval from from pi over 2 to 3 pi over 4, all the way through pi. So pi over 2 to pi, and then it's negative again, 3 pi over 2 to 2 pi. Then D says find the values where R is increasing or decreasing. So this is where you kind of have to understand what's happening from one to the other. So if it's going from 0 to 5, these values are going to be increasing. From 5 to 0, these are decreasing. 0 to negative 5, these are decreasing. Negative 5 back up to 0 are increasing. 0 to 5 increasing, 5 to 0 decreasing, 0 to negative 5 decreasing, and negative 5 to 0 increasing. So if I write all those out, increasing from 0 to pi over 4, from 3 pi over 4, this goes twice, so to 5 pi over 4, and then again at the end there, 7 pi over 4 to 2 pi. It would be decreasing here from pi over 4 to pi over 2, and then it keeps going, so to 3 pi over 4. Here to here, 5 pi over 4 to 7 pi over 4. Then the last one says to state the intervals which the distance R from the pole is increasing or decreasing. So remember, we're looking at the R values. If the R's are positive and increasing, distance is increasing. If R is positive but decreasing, distance is decreasing. So if I do those first, if I look at my positives and increasing, highlight a different color, positive and increasing. Positive and increasing. Those distances are increasing. So distance increasing from 0 to pi over 4 and from pi to 5 pi over 4. Now the distance is also increasing if R is negative and the values are decreasing. So negative and decreasing happens here. And negative and decreasing happens here. So I'm going to add those on. That would be pi over 2 to 3 pi over 4 and 3 pi over 2 to 7 pi over 4. Now we're going to look for where the distance is decreasing, which means positive and decreasing, positive and decreasing, positive and decreasing, and negative and increasing, negative and increasing, negative and increasing. So pi over 4 to pi over 2. 3 pi over 4 to pi, 5 pi over 4 to 3 pi over 2, and 7 pi over 4 to 2 pi. So we did not graph the curve at the beginning, but this would have been 0, 0, pi over 4, 5, back to 0, 0, Then 3 pi over 4 gives you the negative 5, which goes on this side. 5 pi over 4 gives you a positive 5, which goes on this side. And 7 pi over 4 is the negative 5, which goes to that side.